Another interesting unsupervised learning is clustering. So basically, when you have this data set, it looks like there are clearly three different clusters. This is first one, second one, third one. And from this clustering, maybe we can do something great thing. So from the same cluster item, we can extract some common information, and from that you can more easily predict something. Okay. Machine learning is always the process finding hidden patterns from the data. Even the supervised case, in that case, we try to extract some pattern that well describe input and output pair. In this case, we want to find, in the unsupervised learning case, we want to find out pattern inside just input features, so that from the pattern we can more easily understand the input behavior. And that is sometimes very useful to do some next step. Okay, so clustering is also very important task and very important research topic in machine learning. Okay, so how can we automatically find the clusters? So here I drew blue circles from my view, my vision, and my conjecture. Okay, but it will be very nice if we can design some algorithm that can automatically extract such clusters. One very famous algorithm is K-means. This is very practical, and many people use K-means algorithm for clustering purpose. Okay, so what is the K-means algorithm? It's very simple. You first set the K, the target number of cluster. Okay. At the beginning, you don't have any knowledge on the clusters. So at the beginning, you just randomly guess what is the cluster index of each point. So it's kind of coin tossing. Okay, I think, so let's remove my conjecture. So what is the K-means algorithm? At the first time, just random guess. Okay, with the probability 1/3, I think this point belong to cluster 1. I think this point belong to cluster 2, and the remaining point belong to cluster 3, and so on. Okay, so this is just pure random guess, and we cannot expect much of things from the random guess. This is just random guess, roughly 1/3 of accuracy we can expect. Okay, but from this random guess, fortunately, with very high probability, every time we can expect very little bias toward each cluster. So blue point may be little bit biased to some one of clusters, and black also little bit biased towards something, and red point also. So basically, let's say this is the center or median point or average point of entire data point. Maybe blue data point biased towards something here, black data point biased towards something here, and red data point biased towards something here, and so. Now these 3 points are cluster center. Now we classify all the remaining items to the closest cluster center. In this case, all the points here will be assigned to here because this point is the closest data point. I think most of them assigned to blue class because this is the closest cluster center for them. And I think they are assigned to here because they are the distance to, when you compute the distance to every cluster center, then black one is the closest one. That's it. Then we have very perfect cluster. Okay, although the initial was random guess, with high probability the random guess could introduce some little bias, and the bias is very powerful to discriminate all the data points from the biased cluster center. Okay, so this is very ideal case for K-means algorithm. Essentially, K-means algorithm iterates some number of times. So first random guess and find cluster center, and then move to the closest cluster center and recalculate the cluster center again, and then move towards the closest cluster center, and so on. So this is called greedy fashion of update rule because it always look the only the distance to the cluster center and assign to the closest data point. Anyway, so when you learn these K-means algorithms, few steps, then we can expect very nice clustering algorithm. And also because this is totally randomized algorithm, very random algorithm, every time based on the random seed, maybe the outcome can be different.